Welcome to the 10th episode of Apple Finch Pudding, your gateway into the world of science. Today's scientist is Greeshma Gowda, a PhD student in fluid mechanics at Vrije Universiteit Brussels. I have a returning co-host for today, which is Thomas Lebbe, a PhD candidate in macroeconomics with a passion for history. So my first question is always the same. I ask for a fun fact or a joke or a science anecdote. This is for both of you. So I will start with Greeshma. Do you have something for us?
Yeah, so this is something that kind of helped me come to terms with my contribution, or towards my topic, or so, and towards science in general. Sometimes it's easy to feel like you're not really doing enough to make the world a better place or whatever. Yeah. So apparently during the First World War, Einstein decided to use his intellect to come up with an explanation for aerodynamic lift. I'm an aerodynamicist, so this is something that I found very interesting. So he wanted to do something in terms of aerodynamic lift, and he wrote a paper in 1916, and he published it, and he used Bernoulli's principle and equal transit time theory to propose a wing design called cat's back airfoil. So it was basically an airfoil with a really big hump on the upper surface of the airfoil. It looks very strange if you look it up on the internet. And actually, a German aeronautical company, it tested a prototype of this wing and in a wind tunnel, and they found that the results were really disappointing, and the lift to drag ratio was really low. So it was not a very good airfoil, but the head of the facility just wanted to manufacture it, and he wanted to try it anyway. It's called Paul George Earnhardt, and he actually used the airfoil design to manufacture wings, and they put it on an airplane. However, the plane could barely take off the ground, and it apparently almost killed the pilot. And Einstein wrote to the pilot apologizing, yeah, this is what can happen to a man who thinks a lot but reads very little. So, okay. Yeah, like even somebody as smart and talented as Einstein can write a paper which is, for all intents and purposes, useless. So you can draw some comfort in this, I think.
Yeah, we don't have to feel bad when we make a mistake. Even Einstein makes mistakes.
Yeah, indeed. That's something that helped me sometimes.
Okay, yeah, that's actually a good thing to put your life into perspective.
Yeah, indeed.
Okay, and Thomas, do you have something as well?
Yes, and coincidentally, it's also about mistakes and the punishment of mistakes. I'm a teaching assistant at Ghent University, and a few years ago, we decided to change the rules about multiple choice exams. The old system was that there was a penalty if you guessed. So basically, it was the expected value of guessing was 0. So you were not really penalized in a sense, but you didn't get any rewards for it. So you would just get a 0 score and not a negative score. But what we have found is psychological research has shown that boys tend to guess more than girls, and girls would just tend to leave the questions open. But there's still a 1 in 4 chance that your guess is positive. So it was skewing in favor of boys instead of girls. And this was the real reason why we have switched off this multiple choice with penalties towards let's say, a higher threshold for passing a multiple choice test. I think this is something that people don't really know why. And so this is my factoid.
Yeah, oh, that's cool. Yeah, very interesting to see the difference between genders.
Yeah, risk perception is very different. Yeah. And I think we also see this in everyday life. I don't know if you've seen this. I certainly observe it in like just making decisions at work or outside life. It's quite interesting.
Yeah, that's true. And just for listeners that don't know, the previous penalty, I think it was when you get it right, you get +2, and when you get it wrong, -1, or is it +1 and -1?
So basically, it depends on how many possibilities there are.
Yeah.
Yes. Okay. And then basically, if it's +1, then I think it's -1/3 if there's 3 possibilities, -1/4 if there's 4 possibilities, etc.
Makes sense. Yeah. And now it's like you have to get, there's no penalty when you get it wrong, but you have to get like 60% to pass or something.
Yes, that's correct. 60% gets rescaled into to 50, let's say.
Yeah. Okay. So I actually, yeah. So as you know, or might know, my focus is on functioning of plants and stuff. And I was wondering, do you actually know how you can recognize a dogwood tree by its bark?
Oh God! Oh no, this is horrible. This is.
Yeah, I know. It's a horrible joke.
Oh God.
Okay, so Greeshma,
Yeah.
you work in fluid mechanics, but what do we have to envision when we heard the word or the term fluid mechanics? What does that mean exactly?
Well, fluid mechanics, it's a broad field, right? So fluid mechanics is basically how any kind of fluid flows, and you study how it flows and what are the things that are affecting its flow. What I do is aerodynamics, so it's a part of it. Fluids are all the same, but different viscosities and a little different behaviors, right? So I'm an aerodynamicist, so I study how air flows in and around, mostly around bodies like aerofoils, wings of aircraft, cars, wind turbines, and yeah, other bodies. External aerodynamics is my focus, and mainly wind turbine aerodynamics, because I shifted my focus towards wind energy a few years ago. So I study how air flows around a wind turbine blade.
Yeah, because fluids, I think the general people, when they hear fluids, they think of liquids, but it's not only liquids, it's all gases and stuff.
Also gases. Yeah, air.
Okay.
Air is a fluid.
Yeah. Okay.
Yeah.
You already illustrated this a little, so you work on wind turbines. And what do you study on wind turbines?
So my field of study is vertical axis wind turbine aerodynamics. So if you already know what a wind turbine is, you would be familiar with this idea of like a big mast and a fan on top that you see everywhere. Those are horizontal axis wind turbines because their axis of rotation is horizontal to the ground. And the wind turbines I study, they are not very mainstream yet at the moment. They are vertical axis wind turbines. It's like they have a vertical axis and then they rotate around the axis, something like you have a cylinder rotating around its central axis. Those are the turbines that I study, and specifically my topic is to study this process of synchronization that a couple of researchers have observed at the VUB, in our research group at the VUB, and also in another research group in Japan. So the synchronization is basically a new process that we don't know why exactly it is happening, and we don't know how it would affect the power production of the wind turbine. So my job is to understand why it's happening.
What do you actually mean with synchronization? What does that mean?
Yeah, I'll tell you. So in the system that I am studying, we have two vertical axis wind turbine rotors put right next to each other. There is a small gap between them, and we rotate them using a generator in a lab condition. That's how you do experiments. You have to give power to move things because we don't have wind as it would be in real life. So when we rotate one of these rotors at, say, 1,200 rotations per minute, and then the other one also at 1,200 rotations per minute, and at some point, if I change one of the rotors' speed to 1,220, the other rotor automatically moves to 1,220 instead of just, rotating at its original speed. And we also noticed that since they are at two different speeds, they shouldn't cross the center line at the same position of their blades, but they do. So something is happening there, which makes the other rotor speed up to catch up with the rotor that we are messing with. And we don't, there are some theories, but we don't exactly know what's happening. So I'm trying to understand why this is happening. And we realized the last year or so that it's not really because there is something wrong with the experiment, because that can always happen, because sometimes the vibrations can mess around with your data that you acquire. But it's not what's happening, because we can see the exact same phenomena in simulations as well. So I'm hoping to understand that. I'm still working on it.
I was a bit flabbergasted also about these vertical ones. I wonder, is it always two pillars next to each other, or is it just a specific configuration?
It's one specific configuration that you, but that's what I work on together. But there are different configurations. The default configuration is just one rotor on one mast, and there are also these paired rotor configurations that you mentioned. That is what I work on, and this was because a research group found out that when they are closer together, they produce more power, and they were also studying how. Like what is an efficient way to put multiple rotors together, like for example, side by side, one behind the other, like staggered configuration. And there was a very interesting paper where they used a fish schooling, like how fish group together to get an idea of how to put the wind turbines. It's a very complicated explanation for it, but it's very interesting to read. So there are multiple configurations, and this is just one particular one that I'm working on.
I'm also thinking about the lab conditions, because basically, if I have it correct, basically these vertical rotors, they're two next to each other, right? And then they rotate, and purely because of your condition, you have a synchronization. If you change only one of them, then the other automatically adopts the effect. And but immediately, I also think if you change the rotor, doesn't this also impact basically the airflow around it, because you change the airflow, and because of course the rotors are both making but also receiving it. For me, intuitively, if you're in a confined surrounding, this would make it automatically so, in a sense. So can you also have you also tested this outside, where basically the vessel is infinite in a certain sense?
Real life testing has not been done because first of all, it's hard to test outside wind tunnels. You would have to do a field testing, and for that the scale of the rotors is different than the one we use in wind tunnels. But that is the whole idea. Like the airflow that changes when one of the rotors is rotating faster is affecting the other one. But we don't know how, because it's not something we expect. We expect that there will be changes in the airflow, and this already results in an improved power efficiency. The changes in the flow when you put them both close together already improves things. However, this little thing that is happening, this synchronization, we don't know why this is happening, because there is certainly changes in airflow, but why should the air turning around the first rotor pull the other rotor much faster? There should be an extra force that's pulling the other rotor, right? Because otherwise we wouldn't see it speeding up. But we don't know about this additional force, and that's what we are looking into, because it needs some kind of an external driver to speed up.
Does it also work if you, for example, only start rotating one and the other one is standing still when you start?
Yeah, no, I don't think we haven't tested it, but I would not think it would work. Mainly because one of the problems with vertical axis wind turbines, or they have a starting problem that they need to be jump started, but there's also a lot of research going on how to eliminate this problem.
And these wind turbines, these vertical wind turbines, how large are they? Can you, for example, put one on your roof?
Yeah, indeed. So basically, the scale of these wind turbines, vertical axis wind turbines, they vary a lot. I think the smallest ones can be like 1 meter or 2 meters. So you can put them on top of your house, but the largest ones are also like 100 meters tall. And yeah, so you can actually buy a small vertical axis wind turbine in multiple designs actually off of the internet. I think they cost like a few €100, so you can put them on your house and in your lawn. You can also build one. I have seen many instruction blogs and videos on how to build. So if you're handy and you have, a couple of days, you can build one as your hobby project. They won't produce a lot of power, but it will be fun, I'm sure.
I'm going to be a bit critical. Why should we care about vertical wind turbines if we already have all the other types of wind turbines that are everywhere? What's the added value, the advantage?
When you choose a technology in real life, most of the times you're also trading one set of compromises to another different set of compromises, right? So these vertical axis rotors, they have their own positive attributes. They are easier to maintain because they have a gearbox at the bottom instead of at the top, like a horizontal axis wind turbine. And they also they can function with a lower wind velocity, and they produce less noise. And they can be put in terrains, some terrains which are not ideal for horizontal axis wind turbines. And another big advantage is we have this effect. We have this problem called wake effects. When you have two horizontal axis wind turbines close to each other, what happens is the airflow from the first turbine, when it hits the second turbine, if the second turbine is too close to the first turbine, the power production can be negatively affected because of the characteristics of the wake of the first turbine. So what we do in horizontal axis wind farms is that we put them far apart. If you have seen it, they are really far from each other. So ideally, if you have a vertical axis wind turbine, you would not need this much space between them, because what we are seeing now is that instead of hindering the power production when they are close together, it actually helps them produce more power. There are a few papers on studying how how to stagger them in a way that they can produce more power when they're closer together. So this could be an advantage as well over the horizontal axis wind turbines. I'm not saying they will replace them, but they certainly have their own advantages. And for me, they are very interesting because of their aerodynamics. They are much more complicated than horizontal axis wind turbines in terms of just the physics that goes on around them. That's something I find fascinating, but it doesn't have real world application, the fascination, but yeah.
It has to be fun for you as well, right?
Yeah, indeed, of course.
Okay. But you said they turn when there's a lower wind speed, but they also have like a starting point they have to reach. So are they actually more efficient or less efficient than the horizontal wind turbines?
They are less efficient. When you compare a horizontal axis turbine and a vertical axis turbine as individual rotors, they're less efficient, mainly because they are working with unsteady aerodynamics, which makes the airfoils in the blades enter this process called stall, where they produce less lift, so less power. However, they have their advantages, like I mentioned, and there is a lot of work going on as to how we can improve the efficiency of these. Horizontal axis turbines have had like decades of research behind them. We have improved them so much over the past 50 years or so that hopefully if we put that much effort into vertical axis wind turbines, they can also be in the same place. But time will tell, I think.
Also, I think then this is basically efficiency in terms of one unit of a wind turbine. But you could also think with your remark that you said about the efficiency per square kilometers. And because you can stack them together and you said you have efficiency gains, maybe, I mean, land is scarce and we'll never get more land. So this is also another way to look at the problem, I assume.
Yeah. Indeed, yeah, because there are some studies which show like a whole factor of improvement in power density of a vertical axis wind farm compared to a horizontal axis farm. So that's a really big improvement if we can translate that to real world circumstances.
Are there actually like large vertical wind farms?
No, just the data comes from a farm, like an experimental study that they did in an experimental environment outside, of course. But yeah, we don't have that many real world applications for VAWT yet. However, there are a few companies which are working on it, and I think there is one called Agile Wind in Germany, which is testing a land onshore turbine, which was 105 meters tall with 32 meter diameter or something. And then there is also another company in Norway which has working. It's been 7 years since they installed an offshore turbine that they've used for testing, and they plan to build larger ones. I think if I'm right, they're going to build a 2 megawatt one. I heard, or 1 megawatt one. I'm not. Yeah, I don't remember exactly, but a large turbine.
So do you think that is the future actually, to have like large wind farms with vertical wind turbines?
Optimistically speaking, yes, I would love to see that. And I also think it's not a bad idea because we have a lot of advantages on our side, and people are working on it, and it takes less space and we can fit more in. So why not? And also, yeah, none of the countries in the EU or anywhere else have reached not even half their goal for renewable energy. So this might help because they are easier to install and to maintain and cheaper in terms of manufacturing. So it could be a solution. But we still need a lot of research and improvements in it, of course, before we go on building them, because we don't want to waste the resources.
One of the problems we always have with renewable energy is it's time dependent. So is there a way we can store that energy in some way? Like, I know they have large batteries, but is that the way to go?
So again, I have to tell you that it's again not something that I am well versed in, but I do know a few ways. So we have these electrical and lead acid batteries that are used for general purposes. So they are the most used power storage mechanisms. But we also have new technologies that are coming up, and also some like hydrogen cells, where they use the energy produced by the wind turbines to produce hydrogen from water, and they store the hydrogen carefully. Well, that again is a big process, but this is what is quite popular now, hydrogen as a power storage system. And I've heard a lot about it in the conferences I've been as well. So this is one of the things that we can see in the future. But I also know that there are ways to compress air using the excess power and then store that air and use it later to drive turbines. To produce energy. And I think like last year or so, there was another really innovative solution for this, where they would use, I think it was a Dutch company, if I'm remembering right. They proposed an idea where they would use this extra energy to pump water into these flexible elastic bladders which lie on the bed of the sea, and then they would use this pressurized water later to run turbines, different kind of turbines, to produce electricity later. But that was very interesting. I think there are a lot of innovative solutions out there, and how effective they are is yet to be seen, but there certainly are options. And also think that people who work in research and also industries are realizing that they need to invest more in grid infrastructure to efficiently use the energy that we are producing. Working on that would certainly improve the situation.
Well, that also made me think of something I heard a few years ago, where one of the ideas was to construct like a ring island, and when they have available energy, they pump up the water within the ring, and when they have a shortage, they let it out again, and that drives a turbine, and then you always lose energy in the conversion, but it's a way of storing some of the energy.
Yeah. That's I think it's also like the idea of compressed water. Yeah.
I've heard something similar, but then for countries who don't have many elevations, like Jeroen's, your idea was basically you need an ocean because you need to make the ring in the ocean. Belgium is quite flat, so that's also not an option to build a dam. You always have to look at the geology. But I found another one, and this was basically someone said, okay, we just drill a hole and go very, very deep, and we do a reverse dam in a sense.
Can you explain that?
Well, basically, you just need elevation between two different levels. So it doesn't matter if you drill a hole and make like a reservoir deep into the ground, or have something high up. The idea is still the same. You just have the change of elevation. So for countries like Belgium, this could be a potential solution, which is a very smart way to think about something that has, seems complex, but really isn't.
Yeah, pressure difference.
Yeah, exactly. In energy, we also talk a lot about modularity because, demands shift. People, especially in more developing countries, need to have like small modules and then not per se stay at the same place. We know that in the nuclear sciences, we have these modular small reactors that can be put onto a truck and then moved around. Is there any possibility for these windmills to also be, because you said it was quite easy engineering, the gearbox was at the bottom. It seems the perfect fit for a modular.
I've never really thought about the modularity of these turbines, to be completely honest, but it could be done, I think, because they are considerably easy to install and to maintain. However, I'm not sure if the energy produced by such small turbines would be enough for real purposes, like to light things. Maybe to turn on the lamp lights, it would be enough, but to run a TV or something, I doubt if a small turbine would be enough. This also brings another thing to my mind. So some of my friends from TU Delft, they worked for this company called Kite Power, and when I was doing my master's there, my research group also consisted a lot of people from Kite Power. If you can, you should look it up. So basically, they are using kites to harness wind energy. It's a pretty cool concept, and I think there are also a few bigger companies, including a part of Google, that is actually working on kite power. So that's very, very portable. Like you can bring it anywhere and use it. However, it's not yet mainstream, but it's an interesting concept.
In my head, that's really funny. I just see like a man or a woman with a kite, and that's like, how do you get energy from that?
So you fly the kite, and then the wind pulls the kite away, and you have like a pulley and a gear system. But this was a few years ago already, so I'm not sure about the progress they have made since then. But it's a very interesting concept, nevertheless.
And actually, one of the rumors I heard a few years ago, so I don't know if it's true, but like for wind turbines, I heard that they need rare metals. Is that true actually? Are we like depleting some kind of metals for producing these wind turbines, or is that just a rumor?
So the blades of wind turbines, they are made from fiberglass, reinforced polyester or epoxy, and carbon fiber or Kevlar are used as the support structures inside the blades. And I think recently they're also using wood components for this. and the masts are made from like steel or concrete. So I am not sure if there are rare metals being used, but maybe in the gear system or energy transmission system, but that would be the case for any other energy resource as well. And another thing is a lot of companies are working on making use of the blades as well. Because that was a big thing about like, okay, at the end of the life cycle of a wind turbine, the blades just kind of go to landfill. And that was true a few years ago, but now they are working on like recyclable blade designs. There are some companies which are kind of crushing the blade and using the epoxy to make other things. And I also have seen in Rotterdam, they have made like public benches with wind turbine blades. So that's pretty cool. I saw it last time I was there and I was quite impressed. You're trying to use it in one way or the other. So hopefully in a few years, the carbon footprint will decrease even further.
And as you know, we have an extensive energy crisis right now. Do these wind turbines, can they help with this energy crisis, or is it like a drop in a bucket?
So wind it's a local energy resource, right? So for a lot of countries in the world. So ideally it helps because you don't have to buy energy from anywhere else, and it's right there and you're just using it, and it's also not making a bigger impact on your environment and atmosphere. It has the capacity certainly to help, I think. I think at the end of 2021, it was estimated that like around 16 to 17% of Europe's electricity demand is being met by renewables, and especially wind. And I think Denmark has close to 50% of its energy needs being met by wind energy, and Ireland is around 40%. So like I mentioned earlier, we haven't, like the EU has not managed to reach even half its goal of wind turbines, and we're already at 16, 17%. So if we can manage to reach the goals, I think it certainly can put a big dent in the crisis. But we have to get there. And so with the right policies and right actions, I'm sure we can help the crisis. We know already that it's not futile, right? Because 16% is a large chunk.
Unfortunately, I have to disagree completely with whatever I've heard right now. I work on energy and macroeconomic policy around it, and basically it is the least efficient energy producer that determines the price. And so only when the wind turbine is in effect the least efficient one to determine the needs, the demand for the energy, that all the rest of that would determine the price. What happens now, basically the gas, we need very inefficient gas centrals to meet the demand for energy. And so they basically just work on the margin. They don't really make a profit, they don't make a loss. But all the other energy firms, whether they be nuclear plants, whether they be wind turbines, they make huge profits. So if you would add another windmill or another 100 windmills, it wouldn't make a big of difference, because we would still need these very inefficient gas centrals. It's only if we really push them out of the market completely that
so that's actually more a political setting then.
It's a market setting. It's not a political setting.
It's economic setting.
It's an economic setting. It's you either choose the amount or you choose the price, and the other one is determined by the market.
So we would actually have to push out gas completely, which is for now more or less impossible.
Exactly, that's the point. So as long as you need one gas central, the prices will remain very high.
Yeah, that's why I mentioned, like, with the right policies, and maybe certainly requires cooperation on multiple fronts, right? Because the people of science, we can't do everything because our knowledge of economics or politics is very limited. At least mine, it's quite limited, just a working knowledge. We need policies and we need people pushing for these kind of things. And
But if you have like the wind turbines on our roof or in our garden, then it will help because we use less energy in our house, so we pay less.
Yeah,
This is true.
Yeah, that's the end goal, right? To make these smaller turbines more mainstream, or make different kinds of turbines more mainstream, and yeah, the accessibility is different for different designs of turbines, and that would probably help people get more interested and
yeah, and they're only the size of a chimney, so that's doable.
Yeah, 1 or 2 meters. It's a small one. Yeah.
So is the idea to become like the new solar panels, that we also, on the consumer level, on the individual level, we use them in our homes? Or is the focus of your research more to do it big scale industrial?
Like at the moment, the focus is, I think, being shifted from smaller scale towards larger scale offshore wind turbines. My work does not concern this at the moment, but a general atmosphere is to make these a viable candidates for offshore wind energy production. Yeah, to build large wind farms on the sea. But there are also people focusing on smaller wind turbines. So the small wind, it comes under, these smaller ones come under small wind research, and that's a little bit different than the ones who work on offshore, because their focuses are a bit different.
That also begs the question, where should we construct those? Because not everywhere you have a lot of wind. Yeah, you mentioned offshore. Offshore you have a lot of wind, but not every country has an offshore. So where should you construct those ideally?
This question really depends on what kind of turbine you're using and what scale of turbines you're using. And they don't always have to be offshore. There are a lot of countries which have plenty of wind resource on their land as well. Like, for example, where I come from in India, there are lots of hills, and there are so many wind turbines on each of these hills. You get confused, like, okay, where am I? Because there were hills a few years ago, and there's just turbine. I'm happy about it, but some people probably won't be. So it really depends on what kind of turbines you're talking about. There are also resources available from different research institutions online as to where it would be ideal to put these turbines. So it's a very complicated question to answer, I think, at least for me.
And Greeshma, you're doing this research and you're in academia, but what do you like about academia, or what don't you like about academia?
Well, I'm still in the beginning of an academic career. I'm in my PhD, so I probably have not seen the early phases of academia, as people say it. But what I like about working in the research field is that I get to learn so many things. I like understanding how things work. I've always been curious about like figuring out things, and I think I like knowing how things work, and that kind of pushes me to learn how things work. So this, it's really, academia really facilitates this learning, and I like that. And I also realize that I like interacting with students that I teach. They're quite interesting conversations sometimes, and I also appreciate the fact that I get to work with a lot of smart people who know a lot about what they're doing. It's very inspiring, the amount of knowledge they have, and that's one of the things that I like about academia. But I've also heard a lot about how a lot of people dislike it because it's a rat race to publish and to get grants, and most of the times, you're just doing like project management stuff and trying to put out fires. So I have not experienced that personally, but I've heard people talk about it, and I don't think I would like that. And I also think that it's quite stressful to be an academic because you're always having to do things. It's always your responsibility. you cannot just say, okay, you know what, I'm going to take a holiday and not think about your work. At least for me, I take a holiday and I'm still thinking about my work. And I don't think that's a great way to go through life, because you've got to unplug and be able to have fun, enjoy your life a bit. The stress, I'm not a big fan of, but the learning I like.
And it also depends on your job. Like I work with plants. Now that's less of a problem. But during my PhD, it's hard. Like in the growing season, I cannot take a holiday because my plants are growing. I have to take care of them. And also plants don't know it's weekend. You have to be there.
Yeah.
Yeah.
I have quite a few plants, house plants, so I understand.
So yeah, you're still at the beginning of your career, but do you think you want to stay in academia long term, or do you think you might shift to industry or something?
I might want to shift to industry after my PhD, or probably after a while, because I want to see real impact of what I'm doing on a day-to-day basis. I think I lack that kind of gratification in the work that I'm doing now, because it will take a while for whatever I'm doing to have a real world impact. And for me, one of the biggest reasons that I moved towards renewable energy is to do something to make the world a better place, you know, to make some change, positive change. I know it's really audacious to think what I'm doing is actually doing any considerable impact, but I think every bit helps, and I want to do something more direct.
No, I get that, and I don't think it's audacious. Actually, we have to do something we like, and I think most people want to make the world a better place. And like you said, every bit helps. So that's not audacious. Yeah. I think it's a good drive.
I still want to be in science, but
is that actually your major drive for doing science, to help the world?
Yeah. To be honest, I've always been interested in science, because I like learning things, but the curiosity was one of the main reasons. But the reason to choose something like renewable energy, it certainly is. I would really like to do something positive, you know, because we have to do something. We've done enough harm to the planet and animals, so we gotta do something positive. And individual responsibility matters, in my opinion. That of course, everything needs help from policymakers and corporations. But if individuals don't want to change, then nothing's going to change, right?
So that's a real passion of you. Is it something that you always had, like as a child? Did you always want to help people or do science and find out how things work?
Yeah. So my parents are both educators, and when I was a child, they would take me to their schools, and I would just walk around the school looking into classes. Probably not the greatest thing to do as a child, but I had fun. I would go to these like the labs to watch the experiments from students, and I would see all these preserved specimens in the lab. I once broke an octopus. The preserved octopus specimen, because I thought it was like it was moving, and then I got scared, and then I knocked it. I spilled mercury once at my mother's school, and the lab assistant and I had to kind of scoop it up, because you can't touch it. You have to scoop it up with sheets of paper, and then we had to clean the area. And my dad taught biology and sometimes chemistry as well. So he would do some cool experiments with me at home. We once tried to build a solar cell with an old transistor that we found in the school, and we also tried to build a metal detector, and it didn't work because it's a complicated thing, but we were trying to build it at home, and once we copper plated the keys to our house, and then we tried to build a drip irrigation system in a tub for plants. So this is how I used to spend my summer holidays, because my parents were very encouraging in terms of science. I think most Indian parents are very encouraging when their child wants to do something sciencey. And my mom, she reads a lot, and she also kind of encouraged me to read. And I used to read a lot of books related to scientists, and when I was a child, and all of these things kind of inspired me to want to, do something cool. And I thought, science was cool. You could do experiments, and you could, build stuff, and that was fun. And when I was in school as well, I found some friends who were really interested in like physics and space exploration and science in general. And then we would like write things down in a notebook that we learned. When I was in school, internet was not really it was not a thing, at least where I was from. I'm from a small town in the southern part of India. And one guy had internet connection in his house, and then he would like print out things and he would bring it to us, and then we would sit and read. It was fun, probably a bit too dorky. I never went to play outside, but it was fun. And I appreciate the fact that I had friends like these in school. They're all still doing good things in life. One of them is doing a PhD in applied mathematics, and the other one I think is working for a engineering firm. But so it was fun, and I liked doing these things. And later on, I got interested in airplanes because they were cool, and I wanted to be a pilot first, but I realized, okay, maybe learning how they work is probably more interesting. So I did, I chose the field.
So is that how you got into fluid mechanics?
Actually, no. So I did aeronautical engineering during my bachelor's. And so one of the things, I was really bad at aeroelasticity and structural engineering. Well, I shouldn't say really bad. They were not my favorite. And thermodynamics was always, I'm not very good at thermodynamics. So the other interesting, it was aerodynamics. And then I really liked how, lift is like magic. It's just like, okay, air flows on top, air flows on bottom. Okay, you're lifting an entire aircraft, which is thousands of kilograms up in the air, with just pressure difference. That's a ridiculous thing, right? So this is what made me feel like, shit, this is magic. I should learn more about this. I read the book that was prescribed, and it was really interesting. So I decided, okay, you know what, maybe I will learn more about this. And when I had to choose a major for my master's, I said, okay, I'm going to choose aerodynamics because I clearly really like it. And I also liked doing CFD simulations in my bachelor's. They looked cool and colorful. And it was like, oh shit, I'm waiting for my simulations to converge. Sounded much cooler than, I don't know, something like, I'm doing some structural calculations. To be honest, they also use simulations, but that's why I decided to study aerodynamics. And here I am rambling on about it.
Oh, no, but it's great. And given that actually you grew up with science, it has been a big part of your life. Do you know what you would be if you weren't doing science, or if you weren't a scientist? Maybe a pilot, I guess.
I don't know. I would like to think I would be a wildlife conservationist, because that was one of my passions since I was a really small child. I love animals, and I would love to work with them and help them. So I would like to think I would be a wildlife conservationist, but it's quite unlikely, I think. Probably, pilot.
Yeah, okay, a pilot. So, Greeshma, we're getting to the end of this episode. Is there one thing you want our listeners to take home, something they should remember?
I would say try to be curious and do what you can to make the world a better place for the coming generations and for the animals around you, and support science and scientists, and ask your policymakers to take better decisions for the planet and for the people.
Okay. Yeah, no, that's a great take-home message. So This was the 10th episode of Apple Finch Pudding. I want to thank Greeshma Gowda for the information and Thomas Lebbe for the questions. Let's meet again for the next episode of Apple Finch Pudding.